Hi guys, it's Devin Wyndham again. Please support me through PayPal to devinwyndham@gmail.com. devinwyndham@gmail.com is one word, all lowercase. I'll repeat that info in the comments. And please subscribe to my channel. Or ignore the stuff on top. Use implicit differentiation to find dy dx. We're given that x to the fourth plus y to the fourth equals 32xy. All right, pause the video, try it on your own. Okay, time for the solution. I want to start by saying I enjoy math. Like, I'm doing this video just to relax. I want you to enjoy math as well. So tips for enjoying math: 1, use printer paper, because I feel that paper with lines on it, those are for writing English essays, and the lines, the rules are going to get in the way of your math equations and stuff. 2, I like to use a ballpoint pen, because I find that pencils, even though you can erase with them, I find that they're scratchy and annoying, and they're constantly getting dull. Another notation. When I was 14, I moved to France. I noticed the French write their X's like this, and like this. I frequently adopt that because we in the United States frequently just write a plain cross for an X, but that can get confused with a plus sign or a multiplication symbol. All right. Another thing about enjoying math is try to understand as much as you can. So differentiation, implicit differentiation relies on the chain rule. So I guess get a book or something to try to really understand the chain rule and also understand implicit differentiation. I'll try to do my best to explain implicit differentiation. Okay, so to do my solution, first I'm assuming that both sides are differentiable functions of x. All right, if we assume that both, and that's sort of reasonable because that looks, y is obviously a differentiable function of x, y to the fourth is, and we know from theory, again, if you've understood it, and I hope you have the theory that says that the sum of two differentiable functions is also differentiable. X is obviously a differentiable function of x. Let's assume that y is a differentiable function of x. Did I say assume both sides? That's the assumption I'm basically making, that y is a differentiable function of x, because then both sides would obviously be differentiable functions of x. Right, once we assume that y is a differentiable function of x, both sides are differentiable functions of x, so if we differentiate both sides, we'll get an equality. Both sides would be equal. So I differentiate the left side with respect to x using the chain rule. Because of the chain rule, we have to add this dy dx here. All right, for the right side, we're going to use the product rule. The derivative of x is 1. The derivative of y, oh, this is just y, just copied. And the derivative of y with respect to x is dy dx. Again, we're assuming that y is a differentiable function of x. All right, this double arrow I like. It means is equivalent to. So this equation is equivalent to. Okay, we're solving for dy dx. So just imagine in your mind, I sometimes take a lot of mental shortcuts. It's also fun. So we're solving for dy dx. To treat it as like a variable, move it to the left in your mind, and it's gonna, it's gonna have like a coefficient, and then all the other stuff without the dy dx would be on the right. Oh, notice that I canceled the 4's, so we got an 8. All right, so the stuff that ends up on the right side is going to be this, which becomes this, which becomes this, and then the coefficient of our dy dx on our left is going to be this y cubed, and then this negative 8x. All right, so we're done. I'm going to write the numerator so that I'm not beginning with a negative sign. So we have 8y minus x cubed over y cubed minus 8x. Let me repeat that. That's 8y minus x cubed over y cubed minus 8x. So again, please support me through PayPal to devinwyndham@gmail.com, and please subscribe to my channel. Bye for now.